In this video, we'd like to talk about voltages and this amazing device called the Arduino. So if you've been watching the past few video lectures here, what we've sort of gotten to is that if you take two resistors like this and connect them together end to end, and then put a voltage across the pair. In the previous videos, we've been using a 9-volt battery, looks something like this here. So the point is that if you just connect the 9-volt battery across the whole chain of the resistors, and you look at the voltage across the midpoint of the resistors, between the midpoint and say the other side of this lower resistor, which we'll call R2, calling the resistors R1 and R2. If we look at that voltage across R2, we'll find it's always a fraction of Vn. And by that I mean it's some number that could be about Vn, but oftentimes it's less than Vn, maybe a half Vn or 2/3 Vn, something like that. Like if Vn was a 9-volt battery, this could be 4.5 volts between here and here. And the voltage divider has this sort of convenient equation here which allows you to predict what Vout will be as it depends on Vn. So here's Vn here, here's Vout, and they're not the same because we have this fraction of these resistances stuck between the two. So you can go about computing what R2 and R1 is, and you can figure out what the voltage fraction would be. And we did an example in the last video here where if R1 is exactly equal to R2, then Vout, the voltage here, will be exactly half of Vn. That was just an example. So just hopefully you're getting in your mind here how these voltages are measured. Again, I won't make any measurements here, but we of course have our meter here. If we put it in voltage mode, what we're talking about is literally taking these probes here, and if I put the two probes across the whole resistor bunch like that, that would give me a measure of Vn like this, maybe 9 volts if it was a 9-volt battery. And what I'm saying about Vout is if I keep the black probe here at the bottom the way I was doing before, but I don't measure this voltage, I move it down to this midpoint between the two resistors, then Vout will be a number that's often less than Vn as predicted by this equation right here. So again, you're just sort of moving the voltage probes from here to here. Didn't move this one. It's down to here from here. Vn here, Vout here. Vout will be related by that equation right there. Now the interesting part about this, and the reason why this is so useful, is because as we've also seen in some previous videos, is that these resistors here don't just have to be strict resistors the way we're used to thinking about them. These little devices here that have fixed resistances here. Here's a 1 mega ohm resistor, brown, black, green. Here's that 2,200 ohm resistor I've been using, red, red, red. The resistors don't have to be these fixed ones. Oftentimes this first one here will be a fixed one, maybe like the 222 there, excuse me, the 22,200 ohms. But if we make the other resistor something like the photocell, the photoresistor, the thermistor, whose resistance changes with temperature, again this one changes with light intensity, or even the potentiometer, this one changes its resistance with angle that this thing is turned here, then what happens suddenly is that a physical quantity that is something that is reflecting what's going on in our world, like temperature, or light, or angular motion, can now be converted directly to a voltage. How is that possible? Because remember, we're not leaving these strictly as two fixed resistors all the time. This is one resistor right here, and this lower one here can be the potentiometer, or it can be the thermistor, or it can be the photocell. And what will happen then is that the voltage here, Vout, will be an indicator of temperature, or light, or angular position, or any other resistor you can find. The one that we haven't used yet, but we will in a upcoming video, is the microphone here. We discussed very early on in our introduction to the components that the resistance of this microphone changes with sound intensity. So you could very well make a circuit whose voltage output depends on sound. Now the reason why this is so important, the reason why it's very important to sort of get your electronics in terms of voltages is for, well, a couple of reasons. One of the reasons is because you can very easily measure it with a voltmeter. I know that sounds silly, but by not focusing on currents, when we build the circuits as we discussed, we don't have to break into the circuits to make any sort of measurement in there. We can just simply take these voltage probes right here and just stick them right here, and the voltmeter via Vout, the voltage that it reads, will be indicative of temperature, light, angular position, or sound. That's kind of nice. But where it really becomes powerful, where getting all your measurements in terms of voltages like this, often using a voltage divider, becomes powerful, is when you start using the little Arduino here. Let me just tell you a few things about the Arduino. We're not going to pretend to tell you everything about it. There's tons of stuff on the internet about the Arduino which you can investigate yourself. We're just going to focus on our purposes here. Of course, it's a little device that you can plug into the USB port of your computer and you can program it. This is a little computer. You program it on your big desktop computer, but then of course you can pull the USB cable out and the Arduino will run the program all by itself without needing your big host computer. That's what makes it so convenient. This can just become part of your project. What I wanted to point out though was a couple things just in particular for our purposes here. The first one are these lines over here, and by lines I mean there's little pins, there's little holes in those headers on the Arduino that look very much like the pins on the breadboard here, and indeed they are. They're meant to be used in the same way. Like for instance, on these header pins on the Arduino, I can actually take a wire and stick it into one of these pins, and I've made an electrical connection with the Arduino. Now if you look very carefully at this lower header here, they're labeled A0, A1, A2, A3, and A4, and A5, A0 through 5. Now what the A refers to, in this case here, is analog. Okay? Now what the word analog means, and you're encouraged sort of to look at this word up on the internet, it means basically a voltage that can be just about any value. Now the Arduino has its limitations, so it can only deal with voltages between 0 and 5 volts, but that's okay for us. Where you're doing a lot of stuff with a 9-volt battery, we can adapt and we can ensure that we never exceed that. So it can sort of take in a value between 0 and 5. And what I mean by take in is these numbers here, but A0 through A5, 6 different analog inputs basically are little voltmeters. The Arduino can read voltages, and once that voltage has been read, it's available to you inside of your computer program. Inside your little program that you have running in the Arduino, you can do things with those voltages. Now the voltmeter of course has the red and black leads. There's always 2 leads, and I always need 2 places to stick them in my circuit here to make a measurement here. There's only one on the Arduino, but actually the pin labeled GND, ground, is where the other one would be. So here we go right here. These 2 leads right here connected say to A0 and GND on the Arduino, ground. The red would be like the A0, the black would be like the ground, and I'm all ready to go. I'm all ready to use the Arduino just like a voltmeter. And that's going to be the power that we're going to see with the Arduino, that if we can use it like a voltmeter, if we can make circuits that have certain voltage tap-in points that are useful to us, the Arduino can sit like a voltmeter, read those voltages, and react and make decisions based on what those voltages are. And that's a couple of the projects that we'll be doing in some future videos. So that's the power of understanding electronics in terms of voltages, voltage division, maybe some sensors that interact with our world, and this magnificent thing called the Arduino.